Okay, guys, we're going to start with our warm-up today. Eventually, we are going to talk about solving linear systems by graphing. So are we graphing more than one linear function on a line? But again, you're welcome. Before that, I just want to discuss the warm-up that you guys had. I know it made you think a little bit, okay? Number one's word problem on the warm-up, okay? It says you are scheduled to start your job at an oil change shop. 2 hours after you start, a total of 11 cars have had their oil changed. 3 hours later, a total of 14 cars have had their oil changed. Write a linear function to model the situation. What are you given in this problem? Jeremy? That doesn't help me. You're not given everything. Okay, good. Awesome. Jeremy, explain why 5. Very good. In this word problem, you are given 2 ordered pairs. Kind of funny how this is what we did yesterday, huh? Given 2 ordered pairs, and you have to write an equation. Does that seem easier now if you didn't get that? So what's the first thing we do to write an equation? Doug? Good. Find slope. So we get 14 minus 11 over 5 minus 2. We get 3 over 3, which is 1. Once you have slope, Adam, then what? Good. Y equals 1x plus b. Adam, how do we find b? Good. So you plug in either ordered pair, it doesn't matter which one, to find b. So we have 11 equals 2 plus b minus 2 on both sides. We get b is 9. So the equation is y equals 1x plus 9. So this is the linear function that models this scenario. All you need are 2 ordered pairs to write an equation. Adam? Yes. Yeah, good question. Only if it's 1. Yeah. Good question. Any questions on number 1? So the word problems where you're given 2 ordered pairs are pretty easy. Number 6 is where it gets a little bit confusing. So I'm interested to see if you guys figured this out. Emma H., I actually think yours might have been right, now that I look at it. Okay, number 6. Okay, it says, during the time period 1994 to 2004, the annual sales of a small company increased by $10,000 per year. In 1997, the annual sales were $97,000. First thing you should recognize is that the timeline is from 1994 to 2004. That's a 10-year time period. So the initial year in the span that they give us is always 0. And in this case, 2004 is year 10. So there's 10 years that they're focusing on. 10,000 is what? It's increased by $10,000 per year. What does that 10,000 represent, Emma H? How do you know that? Good. The M is $10,000 per year. If you see the key words, per, each, every, rate, that is your slope, which is your rate of change. So I'll say that again. If you see the key words, per, each, every, rate, okay, that means you're given your M, which is your rise over run, which is your rate of change, which is your slope. They all mean the same thing. This makes it easier for us because we're given M. Mary? Okay, Emma? No, you were. I thought you were close. No. So hold on. Let me finish, guys. So we're given slope. What else are we given in this problem? So in other words, in 1997, annual sales were $97,000. Jeremy? Okay, how did you get that? Right. Okay, so So you're explaining it to me, but I want you to tell me what we're given. You're right, what you're explaining, but what is that? In 1997, annual sales were $97,000. I kind of gave you a hint up there. Justin? No. We're going to use it to find the y-intercept. Donatus? Do you know? Thank you. So 3 years after, annual sales were $97,000. In this problem, you're given slope and you're given an ordered pair. They tell us the rate of change, but they also give us a piece of information at year 3. 1997 is the 3rd year in the timeline. So at year 3, we have $97,000. So Jeremy then went further to explain, you start with your equation, y equals 10,000x plus b. Plug this in for x, this in for y. You end up with a linear function of y equals 10,000x plus 67,000. So Jeremy's right. The hardest part of these word problems is figuring out whether you're given 2 ordered pairs or whether you're given slope and an ordered pair. Give me a head nod. Does that make sense now? Is it easier now? Okay. Good. Questions on number 6. Emma H. It's not the y-intercept. It's right here. You okay? I just skipped the work. I can do it if you need me to. Sure. All right, let's just try one more of those to make sure you guys are okay. No. Oh, yeah, B would be helpful. Thank you. I forgot there was a B. Okay, B. Anyone want to tell us what you got? Annalise? Awesome. How'd you do that? Okay. Good job. You could also plug 6 in for x. If you do 10,000 times 6 plus 67,000, you get this. The reason is year 2000 is year 6. So Annalise's way is perfect, but you could also put 6 in for x and you get this. Okay, sorry, almost forgot about B. Questions? Okay, let's go to number 5. I want to kind of walk through this together, but you, of course, you can go ahead of me if you want. And then we'll go over homework. Okay, number 5. From 1990 to 2000, the number of thousand visits by people to Bryce Canyon National Park increased by about 23.9 thousand visits per year. In 2000, there were about 1,102.4 thousand visits to the park. So we still have X being the year, Y is the amount of visits. We have a timeline of 1990 to 2000. What year is 1990 if that's the first one in our timeline? Doug? Good, 0. Doug, what about year 2000? Good. So we have a span of 10 years. The initial year we always represent as 0. In this case, the last one is 10. What's one thing that we are given in this problem? Raise your hand if you know one thing that we're given. Emma M? What is it? Awesome. What was your key word that told you that? Awesome. The slope is 23.9 thousand. I'm just going to write it as 23.9. We know it's in terms of thousands. The key word here was per. Per, each, every, rate. If you see those key words, that is your slope. What else are we given in this problem? I should have more than 3 hands. What else is given in this problem? It's just like number 6. Sean? Good. So how do we write that as an ordered pair? Close. It's not 0 because it's not 1990. 1990 is year 0. Good. It's 10 because in year 2000, which is the last year in this timeline, which Sean told us, that's year 10. Okay, go ahead and write an equation using the slope and that point. And if you get that right, you can try B. No, keep it as 23.9. We know it's in terms of thousands. Good job. Way easier. Yeah, you got it. I know. That's why I wanted you guys to think about them. I was just curious to see if you guys could get them. Good. Very good, man. I'm impressed. Good. And then try B. Try that again. Good job, Sean. Charles, you still working on B? No, I mean like getting the y-intercept, getting the B.
I just plugged those two in.
Yeah. Good. Try this part. Awesome. 4.6. You subtracted wrong. You should do this minus this. Okay, that's why. Okay, equation, Jeremy, what did you get? Good. So before we go on to the next part, anyone need me to explain how to get B? Briar, did you just need a calculator? Is that the problem? Okay. Any questions on the equation? Mary? Okay, go ahead. You mean is your answer for B? No. Doug? Good. 982.9 thousand visits, but we're just keeping it like that. So how did you guys find B? What did you plug in for X, Sean?
I did 23.9 times 5.
Good. So you're putting 5 in for X to solve for B. 1995 is right here. It's the 5th year. So you're plugging 5 in for X to solve for part B. Annalise? Yes. That's fine, but do you understand what I'm saying? So they're asking you about 1995. 1995 is the 5th year in the timeline. So all you do for B is you plug 5 in for X and solve. Years is X. Time is always the X value. Well, you're solving for Y. This is Y. Yeah. Yep, you can round it. Annalise, are you sure you're okay with plugging the 5 in for X? Do you with me? Doing it your way, which is basically using your common sense, of course that's always going to work. You can think through it. But sometimes it's a little bit quicker just to plug it in for X. Your call. Anyone else on the word problems? Okay, very good. I wasn't sure how that was going to go today. Very good. Keep that on your desk for now. I may come back to that. Let's go to your homework. Okay. And I'm going to start with 8.6. Okay, so let's go to your homework. I'm going to start with 8.6. I'm just going to read the answers because I already have them up here. Okay, and I want to make sure I have time for the lesson today. So 8.6, starting with number 8. Okay, I'm going to read them. You ready? Number 8, y equals negative 1/3 x plus 4. Number 9, y equals negative 4x plus 5. Number 10, y equals negative 2. Number 11, y equals negative 2/3 x plus 9. Number 12, y equals 3/2x minus 2. 13, y equals negative 1/2 x plus 3. The reason 13 works is if you have a table and it has a pattern, then we are able to write an equation in y equals mx plus b form. If you are able to write an equation in y equals mx plus b form, bless you, it is always a function. Mary? They're in front of you. They're on there. Yep, they're up there. Any questions on 8.6 before I read the other ones? Yeah, I know this lesson was pretty easy yesterday. You guys did very, very well. All right, let's go to practice 62. Okay, and I'm just going to read them. Are you guys okay if I just read the evens? Okay. Okay, number 2. Ready? I'll wait. That's fine. Okay, practice 62, number 2. Y equals negative 2x plus 1. Number 4, y equals 2/3 x minus 4. Number 6, y equals negative 1/3 x plus 4/3, but you should really have y equals negative 1/3 x plus 1.3. Number, what? Yeah, repeating, sorry. Number 8, y equals negative 3x plus 5. Number 10, y equals 1/2 x minus 8. Number 12, y equals negative 3/2x plus 3.5. Number 14, y equals 3x plus 7. Number 16, y equals negative 1/2 x plus 2.5. Number 18, y equals negative 6/5x plus 2. Mary. And 16, yeah.
If we don't have it as a decimal,
I will not take off. Just in regards to graphing, sometimes it's a little bit easier, but you guys know how to convert a fraction to a decimal, so I'm not concerned. Annalise.
I have 2 things. First, sometimes I'm forgetting to like y equals in front of them, and I'm just having like for number 2, I just typed negative 2x plus 1.
Okay, well, you need to have the y equals in there because it's an equation, not an expression. Yes, because you need to write, if it says write an equation, Annalise, you need your y equals. If you just have negative 2x plus 1, that's an expression. So even though it's right, you're not answering the question. Okay? Mm-hmm. It should be minus 8. Number 10, you have slope is 1/2. So then you're plugging in, Annalise, negative 7 and 2. Okay, so you have negative 7 equals half of 2 is 1, and then minus 1 on both sides. Okay. Doug? Y equals negative 1/2 x plus 2.5. MH? Yeah. Okay, so let me just do the slope. So on 16, come on, smartboard. You have negative 1, 3 and 5, 0. x1, y1, x2, y2. Okay, so Emma, m equals 0 minus 3 over 5 minus negative 1. You get negative 3 over 6, which is negative 1/2. You had that? Oh, you said your b is what was wrong. Oh, I thought you said m was wrong. Okay, your b you have 3.5 instead of 2.5. Gotcha. So next step, y equals negative 1/2 x plus b. What point did you use to find b? First one or second one? Do you remember? First one? Okay. So 3 goes in for y. Okay. There you go. Matt. Okay, 2. 2 is y equals negative 2x plus 1. And 4, y equals 2/3 x minus 4. Alyssa. I'll give you my answer key in a second. Anyone else on practice 62? Give me a thumbs up, thumbs down, thumbs down on last night's homework. Okay, just making sure. You look at just my y equals equation. Okay. All right, guys, let's go to notes, page 27. Notes, page 27. If you have your calculator, I think I'm going to show you something today. So if you have it out, I may be able to do the lesson with the calculator as well. If not, just listen, Briar, you'll get it. Page 27 in your notes. Okay. Oh, good. You okay? Good. So before we start, okay, so this title is Solve Linear Systems by Graphing. What do you think we're going to be doing? Donatus? Good. Graphing two equations. Why? What's the point? Why do you think we're going to be graphing two equations? Briar. Okay, good. Donatus? You're right. Very good. Very good. So we're going to graph two equations. If they have an intersection point, we're going to find it. That's going to be the solution for both equations. Okay, so let me show you what I mean. We're going to focus in on page 27 on example 1. Page 27. 27. Example 1A. All right, solve each system by graphing. So let me say this. Graphing is not the only way to solve for two equations. You can use something called elimination. You can use something called substitution. You can use something really cool called a matrix, which is on your calculator. That's my favorite way to solve these. But your book only shows you how to solve systems using graphing. They think you guys can't do the other methods, but I know you can. Okay, so let's solve this using graphing. Matt, we're going to graph this first one. Where do we start with graphing? Good, start at 1. Jeremy, after we start at 1, then what do we do? Right. What's the rise over run? What's in front of x, Jeremy? What's in front of x? Can't see it, but it's there. Okay, 1 over 1. So tell me what to do. Up 1 over 1. Up 1 over 1. Carefully, neatly connect your points. Okay, Briar, where do we start the second equation? Start at -1/2. So neatly put your point halfway between that 0 and -1. Okay, Justin, now what? No, say that again. You said that wrong. What's your rise over run? Good. Down 1 to the right 2. So down 1 to the right 2. Down 1 to the right 2. Now let's do an opposite point so we can make sure we find the solution. Up 1 over 2. Up 1 over 2. Carefully connect your points. Where does it look like they intersect? If you had to take a really good guess, Annalise, where does it look like they intersect? -1 what? Good. -1, 0. I agree with you, but we might not be right. So let's take our calculator and check, and then I'll explain further what this really means. If you don't have a calculator, just watch. Come on, smartboard. It's just being, oh, you know what? There we go. Okay. Let's take our calculators. Okay, when you get your calculator, I'm sure yours is faster than mine. Go to the y equals screen on your calculator. Just press y equals. Clear anything that's in there. Oh, smartboard, let's go. No, just clear anything that's in the y. Oh, yeah, if it's in the y equals, yes. Oh, yeah. All right, y equals screen. Let's type in the first equation. X plus 1. Hit the down arrow. Let's type in the second equation. In parentheses, -1/2 x minus 1/2. You can, yeah. because if you don't put in parentheses, the calculator thinks the x goes on the bottom instead of on the top. Just basically, you have to tell the calculator that negative 1/2 goes in front of x. So you have to have parentheses. Shh, Doug, don't yell out. It does have to, Doug. Okay, hit graph. Oops. Ignore mine. I forgot I was doing box and whisker plots yesterday with 9th grade. Okay, so here's our graph, which looks just like the graphs that we did by hand. Does everyone's graph look like mine? Adam, what does that mean? Okay, okay. That's because you didn't clear everything out. Oh, I don't know why, actually. Don't worry about it for now. Alyssa, does yours look like mine? Probably because you use the minus button instead of the negative button. Guys, please quit kicking that, Zach. Okay, anyone else is not graph? Well, yeah, but your graphs do. All right, yeah. What happened? Doug. Okay, I'll fix it. If you just go to Zoom 6, it takes you back to the normal screen. But now where'd your graphs go? Okay. All right, so here's what you do. Watch, guys. We're going to go to second trace. Second trace. What number do you think I'm going to press?
0.
Right here, Mary. It's highlighted up here. Second trace. Number 5. Everyone hit number 5. Okay, Charles, I'll help you later. Your calculator's different. Matt. Shh. Okay, listen, guys. One more time. You should be hitting second trace. All of you except for Charles should have the exact same screen as me. You should, Matt. Hit it again. Second trace. You didn't hit second trace, that's why. You're in the wrong language. You changed your language on your calculator. You must be in German or something. Is it? All right. Everyone that's in English, what number do you think we're going to? Donatus. Donatus, what number? You think we're going to go to value? 5, okay. Why are we going to press 5? We're finding the intersection point. So Matt, just press 5. Now listen. Hit enter 3 times. 1, 2, 3. Do you get the same answer that Annalise told us about where they cross?
Yes.
So, FYI, you can do this on the calculator and you can do it by hand. Why am I showing you how to do it on the calculator? Shh, raise your hand. Sean? No, real reason. Why am I showing you, Justin? Yeah, to check your work. And to be honest with you guys, in future years, I don't think your teachers are going to show you all this stuff on the calculator. I want you to remember it because when you do get to the Keystone exam, you need to know how to do things a little bit faster. So don't forget how to graph by hand. Don't forget how to do this by hand, okay? But yeah, you can use the calculator. It's not cheating. It's another resource. Donatus, yes? Yeah, that's fine. Matt, I'll talk to you later about that. Okay, let's go to letter B, okay? All right, letter B. What is different about this one? Annalise, what's different? Good, they're not in y equals form. So first thing on letter B we need to do is get these in y equals form. So Zach, what do you want to move first on the first one? You got to get it in y equals form. The y or the 1? The 1, okay, so let's minus 1 on both sides. Okay, so we have negative x minus 1 equals negative 3y. Adam, we still need to get y by itself, so what should we do next? Good, so divide everything by negative 3. So I'm going to actually flip it around here. So for the first one, y equals what? What is our y equals equation, Mary? No? Good, plus 1/3, which is 0.3 repeating. Okay, so let's circle that one. Yes, Annalise? Did you do what we did? Did you minus 1 on both sides and then divide by negative 3? Negative divided by a negative is a positive. Negative divided by a negative is a positive. Okay, the second one, Jeremy, what's the first thing we should move to get this into y equals form?
You should divide by 3.
Okay, divide every term, divide every term by 3. Okay, so Sean, what is our slope-intercept form for the second equation? Okay, just making sure I'm not wrong there. Okay, good. Minus 1. So let's graph the first equation. Where do we start with graphing the first equation? Good. Positive 1/3, which is 0.3 repeating. Okay, Justin, now what? Good. Up 1 over 3. Be careful. Up 1 over 3. Connect your point as neatly and nicely as you can. Second equation, Jeremy, where do we start? Here's the second equation. Where do we start? What's the y-intercept? Okay, so where do you start? You okay with this? Okay, well, listen, make sure you're... So start at negative 1, Doug, then what? Up 1 over 3. Up 1 over 3. Shh, listen, don't yell things out, Emma. Okay, connect them. Zach, do the lines cross? No. Adam, what's the problem? Why don't the lines cross? How do you know they're parallel? Good. Slope is the same. They are parallel lines. Therefore, these 3 little dots means therefore. There is no solution. If there's not a solution, that means there is not an ordered pair that you could plug in for this and this that make it true. They are never going to cross. They are parallel lines. They have the same slope. This one that we did about a couple minutes ago had one solution, which meant this is the only ordered pair that you can plug in for both of these, and it makes both of them true. If there's one solution, there is one answer for each of them. Okay, that makes both of them true. It's the only point where they would be the same. If they're parallel, they are never, ever, ever, ever going to touch. Okay, they're kind of boring. It's like train tracks. They just keep going. Annalise. No, it doesn't. No, I don't know. Like, Annalise, all we did, this was positive 1/3, so we rewrote it here. This is positive 1/3, we rewrote it here. It should be x first, then the b. Y equals mx plus b. You want the x first, then the constant. Always. Mary. Correct. And we're not going to do that one because obviously, like Mary said, if we plug in parallel lines on your calculator, you're not going to be able to find an intersection point. But if you try, go for it, it will give you an error, which means there's nothing. That's, yeah. But we're not going to do the calculator part for all of them. Hold on. Doug. Shh. Shh. What is what? You don't need, we'll talk about that later. Not important right now. All right, let's go to letter C. Okay, letter C, I want you guys to put each of them into y equals form and graph them. Letter C, go ahead and put each of them into y equals form, shh, quiet, and graph them. Be right there. Good job. Awesome. Oh, wait. Shouldn't be negative. Oh, yes, it is. I forgot mine. Put a negative in front of my 3. Thanks. I don't know why I forgot it. Make sure they're both in y equals form. Graph each of them if you want to check them on the calculator to make sure that your intersection point is correct. Go ahead. That's not going to be right. Oh, you just graphed wrong. Start at 3, go down 3 to the right 1. That's why. Yeah. Good job. Yep. Good. Mary, that's not right. This should be a -5. You divided everything by -1. Yep. Wait, well, you got to hit enter 3 times. Okay. Yep. Okay, guys, first equation in y equals form should be y equals x minus 5. Second equation in y equals form should be y equals -3x plus 3. Okay, Adam. So when you graph them, here's what the first one looks like. Second one looks like this. Therefore, they intersect at 2, -3. You minus x on both sides, Briar. So then you have -y equals -x plus 5. Divide everything by -1. You okay? Matt? Yeah, so the calculator, after you type them into y equals, hit graph, go to second trace, number 5, enter, enter, enter. Always. It's just a shortcut rather than me teaching you how to move the cursor to the lines and the curves. Just hit enter 3 times. Works every time. Questions? Okay. I'm going to skip D for now. Okay. That's fine. Yes. Okay. I want everyone to look at the board with me. Okay. Everyone just look. Don't write this one down. So I need all eyes up here. Donatus, Charles, Sean, all eyes up here. Okay. First equation, Charles. How do we graph it? Charles, first equation. Look up here. How do we graph it? This is not in your notes. Just look up here. Then what? Good. Up 2/1. Okay. Second equation. Jeremy, what's the first thing we do to get this in y equals form? Okay, Adam, after we add 4x on both sides, we have 2y equals 4x plus 6. Now what? You don't know? Didn't I say Adam?
No.
Yeah, I did. Thought I did. Adam.
Okay.
Adam. I'll just say your name 3 times. All right, Adam, good. Adam. Now what? I'm just going to be obnoxious now. Go ahead. Okay. To graph this, Annalise, where do we start? Good. Start at 3. Emma H. After we start at 3, then what? Up 2/1. All right, what does this mean? Who can tell us? Justin. Say that again. Good. There are infinite solutions. So you can have one solution. You can have no solutions. You could have infinite solutions. Guys, if it's the same line, they share every single point. There are millions. There are infinite solutions that work that make both of these true. John. On a parabola, but we're not doing parabolas. Questions? Okay. Homework. Okay. In your homework packet. Yeah, today went really fast. That's not what we're doing. Hands, okay? Charles, hold on. Homework packet. Guys, listen. You're all yelling out things, and that's not even what your homework is. Page 129 in your homework packet. Front and back. So you're doing numbers 1 to 4. Quiet. Shh, Charles, quiet. And numbers 1 to 6. Okay, so front and back. Numbers 1 to 4 and 1 to 6. Shh, listen. You need to have written down there what the intersection points are. Okay? If there is one. If not, whether it's no solution or infinite solutions. What equation do you have to have them all in? What form? Y equals mx plus b form. So seriously, don't come in tomorrow and say, I didn't know how to graph this because it's 4x plus y equals 2. Do you know where the homework is, Jeremy? You should be looking. Okay. Make sure they're all in y equals mx plus b form. Also, from the word problem page, okay? From the warm-up word problem page, I want you to just do 2 of them, okay? No, I'm going to tell you. Word problem page, I want you to try number 2 and number 4. So from the word problems from today, just try 2 and 4. I just want to make sure. Well, is number 4 your 14? The amount of revenue brought in by the states? All right, fine. In your page, sorry, number 2 and 14. So the word problems, guys, is just making sure you can apply yesterday's lesson. Homework shouldn't take very long. Questions, Doug? Write what on the graph? Yes, your homework, I need to see your graphs. Use the calculator to check. If I don't see your graphs, you're going to lose points. Yeah. Yep. Questions? We good on the homework? Good job today. Let's get packed up.